All right, welcome to The Explainer. So, we've all seen AI get incredibly good with language, with images, but the next big leap, it's physical. This is all about teaching machines to understand our world, how to act in it, not just think about it.
Think about it. That question gets right to the heart of the problem. Our world, it's not some neat and tidy spreadsheet, right? It's chaotic, it's unpredictable, and it's all run by the laws of physics. And for a robot or a self-driving car, if you get that physics wrong, that's not just a small mistake. The stakes are incredibly high.
So here's our game plan for today. We're going to start with the big picture, define what physical AI actually is, see how it gets trained in this kind of parallel universe, look at some amazing breakthroughs from the lab, and then wrap up with what this all means for the future. All right, let's jump right in.
Okay, so we all have these incredible visions for what's coming, right? Super advanced robots, cars that drive themselves, factories that run on their own. But there is a massive fundamental problem that we have to solve before any of that becomes a reality. Look, before a robot can perform delicate surgery or a car can navigate a busy street, it has to have this deep, almost intuitive grasp of our physical world. It has to know things like, how hard can I press? How do things fall? What happens when two things bump into each other? It basically needs physical common sense.
And to tackle this huge challenge, a really groundbreaking new field is taking shape. Researchers over at NVIDIA are calling it physical AI. You can think of it as the engine that's going to power this whole next wave of smart machines.
Now, physical AI, it's not just one single thing. It's really more like a powerful recipe that mixes together a bunch of different fields. Things like neural graphics, reinforcement learning, and incredibly realistic physics simulations. And all these pieces have to work together to finally connect the digital brain to the physical body, to bridge that gap between code and action. And this brings us to a really core idea, which Sandra Fidler from NVIDIA captures perfectly here. It's this incredible feedback loop. The AI gets smarter, which lets us build way more realistic simulations. And then those amazing simulations become the perfect gym, the perfect training ground for the AI to get even smarter. They just keep pushing each other forward.
Okay, so how in the world do you actually train this kind of AI? You can't just buy a super expensive multi-million-dollar robot and let it learn to walk by, face planting thousands of times in a factory. The cost, the danger, it's just not feasible.
The answer, and this is where it gets really cool, is to build what one top researcher calls a parallel universe. We're talking about a perfectly simulated, high-fidelity digital twin of our own world. And inside this virtual sandbox, the AI can try things. It can fail. It can learn millions and millions of times. It can pack a lifetime of trial and error experience into just a few hours. And the best part? Absolutely zero real-world consequences. And the whole training loop looks something like this. Step 1, you capture the real world, just using normal 2D videos and photos. Step 2, the AI takes that and reconstructs it into a full-blown 3D simulation. Step 3 is the training part, running the AI through millions of different scenarios in that simulation. And then step 4, you take all that knowledge, all those skills, and you deploy them back into a robot in the real world.
For decades, computer graphics has been about one thing, going from a 3D model to a 2D image on your screen. That's called forward rendering. The absolute magic here is that AI lets us do the complete opposite. It's a process called inverse rendering. We can literally take something as simple as a video from your phone and build an entire interactive 3D world from it. It's a total game changer. Okay, so this isn't just some far-off theory. Let's dive into some absolutely amazing new research from siggraph. That's the top conference for computer graphics in the world, to see what's actually possible today.
All right, check this out. There is a massive difference between something that just looks real and something that acts real. Older methods could take a video and spit out a 3D chair that looked pretty good visually, but the moment you put it into a physics simulation and tried to, sit on it, it would just collapse into a pile of digital mush. The breakthrough now is creating 3D models that are actually structurally sound. They understand physics. It's a virtual chair that you could actually, virtually sit on without it falling apart.
Okay, that's objects. But what about movement? How do you teach a robot complex, agile skills? Think about something like parkour. Getting real-world data for that is next to impossible. You can't just slap sensors on a bunch of athletes and get what you need. It's too complex, too dynamic. So what's the solution? You generate your own data. Researchers are now able to combine a motion generator with a physics controller, and they can create totally new, totally realistic, physically accurate stunts from scratch.
And this isn't just for making cool videos. This is about training humanoid robots for really critical situations, like getting through a disaster zone where being agile and balanced could literally be a lifesaver.
And it's not just about robots either. This same tech is about to completely change the game for digital artists and content creators. Imagine you're an artist, and you just type in a simple prompt like this.
And just like that, boom, the AI generates these hyper-realistic textures. The weathering, the rust, it all just appears. Something that would take a really skilled artist hours and hours of tedious work can now be done in seconds. This is going to make building rich virtual worlds for games and movies so much faster. But it also feeds back into our loop, right? We can use it to create even more realistic simulation worlds to train even better AI.
Okay, so let's zoom back out for a second. We've seen some of the incredible tech, but what does it all mean? Why does building these parallel universes actually matter to all of us?
Well, the impact is going to be huge, and it's going to be felt everywhere. You've got the obvious ones, like robotics and self-driving cars, for sure. But think bigger, designing smarter cities, making factories way more efficient, and even completely changing how we create games and movies. This is really a foundational tech that's going to make all kinds of autonomous systems smarter, safer, and just way more capable.
All right, so let's wrap this up with the key takeaways. First, remember that powerful feedback loop. AI and simulation are making each other better and better. Second, this loop allows us to build these parallel universes, these safe virtual training grounds that are absolutely essential. And third, the magic ingredient is that we can now build these amazing worlds from just simple photos and videos. And it's that combination that's really going to unlock the future of smarter robots, safer cars, the whole shebang.
And this all leaves us with one last kind of mind-bending thought to chew on. As we get better and better at making these perfect virtual copies of our own world to teach AI, we're also creating this incredible sandbox for ourselves, a place where we can run endless experiments. So the real question is, if we're teaching the AI about our world, what is that AI in turn going to teach us about it?